Hello everyone, welcome to Tech Advisor YouTube channel. And also welcome to our comprehensive guide to the OSI, Open Systems Interconnection model. In this video we'll explore the 7 layers of the OSI model, a conceptual framework used to understand how different networking protocols interact within a network system. By understanding the OSI model, you'll gain insight into the complexities of modern computer networks and how data is transmitted, processed, and received across various layers. What you'll learn. By the end of this video, you'll have a detailed understanding of each layer of the OSI model, including its functions, real-life examples, and associated protocols. Here's what you can expect to learn about each layer. 1. Introduction to the OSI model. 2. Exploring the 7 layers. 3. Applications and real-world examples. Introduction to the OSI model. What is the OSI model? 1. Conceptual framework. The OSI model is a foundational conceptual framework that standardizes the functions of communication systems, providing a common language for diverse technologies to interoperate seamlessly. 2. International standardization. Created by the International Organization for Standardization (ISO), the OSI model serves as a reference for understanding and implementing network communication protocols. 3. Importance in networking. Understanding the OSI model is crucial for network engineers, administrators, and developers to design, troubleshoot, and optimize network architectures effectively. Evolution and significance. Historical context. The development of the OSI model stemmed from the need to create a universal standard for network communication, promoting interoperability and facilitating the growth of networking technologies. Key principles. The OSI model embodies principles of modularity, abstraction, and layering, enabling clear separation of concerns and promoting efficient development and maintenance of network protocols. Impact on technology. The OSI model has significantly influenced the design of networking hardware, software, and protocols, shaping the modern digital infrastructure. Key concepts and terminology. Layered architecture. The OSI model organizes network communication into 7 distinct layers, each responsible for specific functions, allowing for modular development and troubleshooting. Encapsulation and decapsulation. Understanding the process of encapsulation and decapsulation at each layer is fundamental to comprehending how data is transmitted and received across networks. Interoperability and compatibility. The OSI model fosters interoperability between different network devices and systems, promoting seamless communication across diverse technologies. Practical relevance. Troubleshooting and diagnostics. Proficiency in the OSI model equips network professionals with the tools to diagnose and resolve network issues systematically, enhancing the reliability and performance of digital infrastructures. Standardization and compliance. Adherence to the OSI model ensures that networking technologies conform to established standards, fostering compatibility and reducing integration challenges. Educational and career significance. Mastery of the OSI model is pivotal for individuals pursuing careers in networking, serving as a fundamental pillar of knowledge for professional growth and development. Section 2. Exploring the 7 layers. Layer 1. Physical layer. Transmission media. The physical layer encompasses the transmission of raw data over physical mediums, including copper, fiber optics, and wireless channels, laying the foundation for higher layer communication. Signal encoding. Understanding signal encoding techniques at the physical layer is crucial for ensuring reliable data transmission and reception, mitigating errors and optimizing bandwidth utilization. Hardware components. Components such as network interface cards, NICs, hubs, and repeaters operate at the physical layer, facilitating the conversion of digital data into physical signals. OSI Layer 2. Data link layer. 1. MAC addresses. The data link layer is responsible for the unique identification of devices on the same network through MAC addresses, enabling the efficient and error-free delivery of data frames. Switching and bridging. Data link layer devices such as switches and bridges operate at this layer, facilitating the forwarding of data based on MAC addresses and enhancing network performance. Error detection and correction. Robust error detection and correction mechanisms at the data link layer ensure the integrity of data transmission, enhancing the reliability of network communications. Layer 3 Network Layer. Routing and forwarding. The network layer governs the routing of data packets across interconnected networks, utilizing logical addressing to determine optimal paths for data transmission. 2. IP addressing. Understanding IP addressing and subnetting is fundamental at the network layer, enabling the identification and differentiation of devices across diverse networks. Internet Protocol IP. The network layer is synonymous with the IP protocol, a cornerstone of modern networking that enables global connectivity and data exchange. Layer 4 Transport Layer. 01. End-to-end communication. The transport layer ensures reliable end-to-end communication between devices, offering mechanisms for error recovery, flow control, and data segmentation. TCP and UDP. The transport layer encompasses the Transmission Control Protocol, TCP, and User Datagram Protocol, UDP, providing distinct approaches to data transmission tailored to specific application requirements. Session establishment. Protocols at the transport layer facilitate the establishment, maintenance, and termination of communication sessions, ensuring the orderly exchange of data. Section 3. Applications and real-world examples. Network applications and protocols. Web browsing. The OSI model underpins web browsing, with HTTP operating at the application layer, TCP managing reliable data transfer at the transport layer, and IP routing packets at the network layer. 02. Email communication. Protocols such as SMTP for email transmission and POP/IMAP for retrieval operate at the application layer, leveraging transport and network layer protocols for seamless communication. File transfer. FTP and SSH, operating at the application layer, rely on lower layer protocols for data transfer and network connectivity, exemplifying the OSI model's comprehensive application. Network security and OSI. Firewalls and gateways. Network security devices such as firewalls and gateways operate at the network and transport layers, enforcing access control and protecting against unauthorized access and malicious activities. Encryption and decryption. Security protocols at the application layer utilize transport layer encryption mechanisms, ensuring the confidentiality and integrity of data in transit across networks. Intrusion detection. The OSI model provides a structured approach to intrusion detection and prevention, enabling the deployment of security measures across multiple layers for comprehensive threat mitigation. Real-world implementations. Enterprise networks. The OSI model serves as the blueprint for designing and implementing enterprise networks, guiding the integration of diverse hardware, software, and protocols into cohesive and scalable infrastructures. Cloud computing. Cloud architectures adhere to the principles of the OSI model, leveraging virtualization, network segmentation, and application layer protocols to deliver scalable and resilient cloud services. 03. IoT and edge computing. The proliferation of IoT and edge computing technologies underscores the relevance of the OSI model in orchestrating seamless communication and interoperability across distributed and heterogeneous environments. Future trends and innovations. 01. 5G and beyond. The OSI model provides a framework for accommodating the evolving landscape of wireless communication, enabling the integration of 5G and future wireless technologies into existing network infrastructures. AI and network automation. AI-driven network automation aligns with the principles of the OSI model, streamlining the management and orchestration of network resources across multiple layers with intelligence and efficiency. Blockchain and distributed systems. The OSI model underpins the design and implementation of blockchain and distributed systems, facilitating secure and transparent data exchange across network layers in decentralized environments.